In this short presentation, I want to talk about counting and combinations. You may have seen this material before, but the review will be good and hopefully you'll understand it at a deeper level than you have before. That's what I hope anyway. So here's the story. When I was a child, I had 26 different shirts, each with a different letter of the alphabet on it in really bright colors, and 10 pairs of pants, each numbered with one of the numbers from 1 to 10. My parents did this to help me learn the letters of the alphabet and my numbers. How many different ways could I get dressed in the morning? Well, hopefully you realize it's 260. I could take the pair of pants with the number 1 on it and use letter A, letter B, letter C, etc. So I had 26 different ways I could just wear pants number 1, and of course there were 10 pairs of pants. 10 times 26, 260. And if I include my 5 different cool kinds of shoes, then it's 10 times 26 times 5 equals 1,300 combinations. Hopefully this makes sense. By the way, footnote, this is not a true story. No children were actually traumatized to make this video. So this is called the multiplication principle. If a task, like getting dressed, can be broken down into k separate steps, like choose the pants, choose the shirt, choose the shoes, where the first one can be completed in n1 ways and the second in n2 ways, etc., then there are a total of n1 times n2 times n3 ... times nk ways of carrying out the whole task. And it's easier to just do it like we did with the clothes problem than it is to write down that yucky notation. So here's another example. License plate has 3 digits, 0 through 9, followed by 3 letters of the alphabet. How many such license plates? Well, Step 1, choose the first digit, 10 ways. Step 2, choose the second digit, 10 ways. Step 3, choose the third digit, 10 ways. Step 4, choose the letter of the alphabet that follows the 3 digits. Step 5, choose the next letter. Step 6, choose the next letter. So it's 10 times 10 times 10 times 26 times 26 times 26. Pretty simple. Class has 26 students in it. How many pictures can you take with 5 of the students lined up from left to right? Well, 26 choices for the first student, 25 for the second student, 24 for the third student, etc. So 7,893,600. Notice that this is a little bit different from the license plate problem, because in the license plate you could use the same letter repeatedly. You could have the 3 letters at the end be C, C, C. But you can't do that with students. If you're choosing 5 students from a group of 26, you can't repeat any of them. Now a different but related question. A class has 26 students in it and you're choosing 5 of them to work on a project together. How many different groups of 5 are possible? This really is different from the last example, since the order in which you choose the students doesn't matter. For a picture, the lineup A, B, C, D, E is different from C, D, B, E, A, but as a group working on a project, they're the same set of students. So let's call the answer to this problem C for now. C is the number of subsets of 5 elements from a collection of 26 elements. Students, elements, same thing. Of course, putting a letter on it doesn't tell us what it is, but now we're going to solve it. We're going to find it by using a clever mathematical trick. We're going to go back to example 2 and solve it in 2 different ways. So remember what example 2 was. A class has 26 students in it. How many pictures can you take with 5 of the students lined up from left to right? So solution 1, same as before, we break the task into 5 steps. We choose the first student, choose the second student, choose the third student, etc. 26 times 25 times 24 times 23 times 22. Exactly the same as before. But now we're going to solve it a different way. This time we're going to break the task into 6 steps. First, just choose which 5 students you're going to line up for your picture. Just choose the group of 5. And that's the number we don't know. We called it C. There are C ways of doing that. That's just what we called C. Now, once you have your 5 students, from the 5, choose which student to put first. And from the 4 remaining, choose which student to put second, etc. So how many ways can you get your 5 students lined up? Well, C, choose the 5 students, times 5 times 4 times 3 times 2 times 1. Since the 2 solutions must be equal, we get that 26 times 25 times 24 times 23 times 22 is equal to C times 5 times 4 times 3 times 2 times 1, or C equals 26 times 25 down to 22 divided by 5 times 4 times 3 times 2 times 1, And that's equal to 26 factorial over 5 factorial times 21 factorial. Now this last equality may not be obvious. First of all, remember that the exclamation point, pronounced factorial, just means multiply all the way down to 1. So 26 factorial is 26 times 25 times 24 times 23 times 22 times 21 times 20 times 19 all the way down to 1. And to see why those two things are equal, why the last term is equal to the middle one, just write out those factorials and you'll see a bunch of cancellation. Try that, and if it's giving you troubles, just ask me. So the generalization is, if a set has n elements, the number of subsets with k elements is denoted, the notation we use sometimes is nck, also called n choose k or n combination k, and the formula, generalizing from the last one, is nck equals n factorial over k factorial times n minus k factorial. And as an alternate notation, we use this parentheses notation. Notice that's not a fraction in there, and it's still pronounced the same way, n choose k or n combination k. So as an example, at Hannah's Hamburger Heaven, there are 12 condiments you can put on your hamburger. How many different hamburgers can you order with exactly 3 condiments? Well, answer is 12 combination 3, which is 12 factorial over 3 factorial times 9 factorial. Work it out, you get 220. So this is a brief introduction to counting and combinations, which turn out to have lots of interesting applications and can take you lots of different places. But it's just good to get the fundamentals under your belt. Please ask me about this if anything in here gives you trouble.